Hey y'all, happy Sunday and welcome to this week's live Q&A session. This is the portion of the show where we allow YouTube to send out notifications that we're going live. If you're watching this live Q&A on replay, please scrub ahead until this graphic disappears and the actual show begins. If you're watching live and you have any comments or questions, please go ahead and put them in the live chat. But for now, grab a beverage, sit back, and relax while the countdown timer does its thing. Then we'll get started. Aloha and happy Sunday, everybody. Hope everybody is doing well. I know it's getting kind of down to crunch time. 'Tis the season and all that. And I know some folks are having some pretty desperate moments out there trying to get things done and things just aren't working out. We're going to try to work on some of those problems. Today, we're going to continue our conversation from last week and talk about the allowance offset in the profile toolpath and the pocket allowance in the pocket toolpath. And if we have time, I'll talk a little bit about separate last pass in the profile toolpath as well, if we have time. We've already got a bunch of good questions set aside, and we will get to those as time allows and get them taken care of. We can go as long as y'all want. I'll try to get all those questions handled. But first, got to do a little bit of house cleaning here, and I want to say thank you and hello to Steve over at Harneal Media, sponsor of Mark Lindsay CNC.com. He helped me out with a problem earlier this week, and didn't bat an eye. It was just done. And I think I spent more time chatting with him than he took for him to take care of the problem I was having. But that's the kind of service that you're going to get out of Harneal Media. I've been singing his praises from the get-go, and I'm not going to stop until he tells me to shut up. He's come close a time or two, but we haven't reached that point yet. So listen, I'm just going to say it straight. If you're even toying with the idea of a website, a web store, maybe you want to create some merch with your logo on it, or even just a couple of custom T-shirts of your very own design, talk to Steve over at Harneal Media. He can help you take care of all of that. If you're looking at a website, a web store, he'll get you set up. If you're a seasoned veteran and you know all about working with websites and what have you, he'll do as much or as little as you want him to do. He can just take care of the back end and you focus on content. Or if you're like me and have no idea what you're doing, he can set up certain things to be automatic so that when you do one thing, it automatically goes over to your website as well, like he's done for me. It's 100% personalized service. When you're dealing with Harneal Media, you're dealing with Steve, a small businessman who takes care of his clients, takes care of his customers the only way he knows how, and that is 100% personally. And that's the big bonus. He's very competitively priced, I'll put it to you this way, and after a few months you'll wonder how he gets away with doing it so cheap. So do yourself a favor. If you're tired of paying listing fees, if you're tired of paying commissions, if you're tired of your competition being advertised on the same page your product is, head over to harnealmedia.com, shoot Steve a message. He'll work with you. Again, yes, he does take care of folks in Canada. I had a comment on a live stream this week saying, we need a Steve in Canada. My friends, you have a Steve in Canada. Just reach out to him. He'll take care of you. harnealmedia.com. There's a link down in the description of this live stream and every video and live stream on this channel, all 760 some odd proud. It's that way for a reason. Do yourself a favor. Get over there. Shoot him a message. Steve, thank you for everything you do, both here in front of the scenes and way back behind the scenes. I appreciate everything you do, my friend. Thank you. Okay. Let's get into a couple of things here. I see Butch Miller is having an issue. And it's let me bring up his issue here and then we'll get into it. There we go. He's having issues opening downloading CNC Planet art files. If you don't know, CNC Planet art is a huge project. What they're doing is they're scanning famous sculptures, and architecture all over the world. Whatever they can get into, like the Parthenon in Greece. They're 3D scanning this thing, and they're putting these STL files online for folks to download and use in their projects. This is a big, big project. And Butch is having issues. Now, Butch, you say you're having issues opening, downloading. And someone asked what are the file formats, and he said they're STL, but when downloading or extracting, they only download partway, then terminate. Okay, that sounds like an issue with either CNC Planet Art, their server could be busy. They could be going through an update or something like that. Or it sounds like an issue with the bandwidth, not the bandwidth, but it sounds like it may be an issue with your computer or your internet your internet connection. If it is downloading an incomplete file, meaning if the file on their end is not complete and you download it, even though your computer is saying, yeah, it's a complete file, there's something missing in there that's not letting it extract completely. Wendell is saying it could be a provider cap per file. I guess that's possible as well. There are a lot of variables involved. My first suggestion would be to go over to CNC Planet Art and see if they have a contact us or a support link or something like that, and report the issue to them. If it's on their end, they need to know about it. If you are downloading files that appear to be complete, but aren't complete when you go to extract them, there's an issue on their end. If you're not getting complete downloads, that's an issue on your end. Now, Michael Mazalek, how you doing, Michael? Says he's had that issue when staying in a hotel. Sounds like the hotel restricts the size of the download. I didn't think about that, but that is another variable to throw in the mix. If you're on Wi-Fi somewhere other than your home, that might be an issue. If you are at home, look at your network. Look at what you've got set up. Are you trying to do this wireless via Bluetooth or Wi-Fi or whatever? Okay, Andy Visley says, with Windows 11, you need to OK and trust the file before it will show it as complete. That's another one. There are a lot of variables is what I'm getting at. My first thing would be to contact CNC Planet Art. My second thing would be to contact your internet service provider and make sure there isn't some cap somewhere in there. You know, Crafty Jans is saying, that's Kurt over at Crafty Jans, my ISP has no cap and I've downloaded mega gig files. Same here. But I'm also on a wired connection. I'm not doing anything wireless. You know, I'm hardwired. The router is hardwired to the modem, and my computers, all of my computers are hardwired to the router, to include this one. Yes, I ran a Cat 8 cable from the shop into the house and plugged in. So there's an issue there on one end or another. But it sounds to me like a transfer issue and not necessarily an issue with the file itself per se. Now, having said that, ask a friend if they can download the file you want, because I saw you mention you need this for a client or customer. Have a friend download the file you want and maybe put it in a Dropbox or a Google Drive and see if you can download it from that. Totally bypassing CNC Planet Art. So divide and conquer. If you've got a bunch of variables, you try to eliminate each one to focus in on what the real issue is. Because if you can't download it from CNC Planet Art and you can't download it from Dropbox or a Google Drive or whatever, then the problem's your end. Especially if the other person can download that file and import it into VCarve or Aspire with no issues. So, I mean, we can work on it. We can work on it. Okay, I know that was completely off topic, but again, I mentioned as we opened, there's a lot of frustration with people trying to get things done. It's crunch time. I get it. I understand. And sometimes you don't care how, you just want the thing to work, you know. So, anyhow, let's go ahead and let's get into this. We're going to get into, I'm going to do it in Aspire this time, but this works exactly the same way in Cut 2D and VCarve, Desktop and Pro, and Aspire. Okay, quick pause. That's what distracted me. Butch says, my internet may be the issue. I only have satellite. Contact your provider. Contact your provider. Jack in the shop is on board. All right. Okay, let's get into it here. Let me bring up Aspire. And again, like I said, this works exactly the same way in Cut 2D, Desktop and Pro, and VCarve Desktop and Pro. I'm just using Aspire today because that's the button I pushed. All right, what we're talking about when we're talking about allowance offset is we're talking about an option that is right here under Machine Vectors in the Profile Toolpath. Okay. In order to get into this, we're first going to have to go up here to Machine Vectors and to understand what's going on. When we get into Machine Vectors right here, what we're looking at is whether we're going to cut to the outside or right of the vector, the inside or the left of the vector, or on the vector. Okay? Now, I'm not going to talk about climbing conventional right now because it doesn't really pertain to what we're discussing. We're talking about the allowance offset. Now, we're going to use a closed vector for this first demonstration, and we're gonna be recalculating toolpaths till the cows come home, all the cows, that is. The purpose of an allowance offset is to create either an overcut or an undercut. Okay? An overcut will cut slightly smaller, where an undercut will cut slightly larger of the selected shape. Okay? If our allowance is 0, which is the default, it's going to cut to this exact size. But if we want it to overcut, and this is where people get confused, we're telling it to cut to the outside of the vector. If we overcut, it's going to cut further inside because we're overcutting this. If we want it to undercut, it's going to cut to the outside of this. Meaning it's not cutting to this size. It's undercutting, meaning it's cutting somewhere out here. All right? If we're overcutting it, we're cutting into here. Okay? So in this case, with a closed vector, we're going to use a negative number to cut this smaller. If we wanted to cut further out here, we'll use a positive number. Now this is on a closed vector, remember, okay? We're cutting to the outside. I'm going to use a crazy number that we would not use in a normal situation, but a crazy number is needed to demonstrate, to show you what's going on here. Okay, and let's go with a 1/4 inch allowance offset. All right, that's a positive number. Okay, we've told it to cut to the outside. We're going to go with a positive number for our allowance offset, and I'm not going to change anything else. And I'll just leave it called profile 1, and we'll calculate it. Well, cancel. Let me go back up here and check my, yeah, I've got it to cut through. Let's go with a 1/4 inch deep, 0.25. All right, now we'll calculate it because I don't want it to cut through the material. All right. In my options, I turned off the option to have it jump straight into the 3D view. Okay. Now, let's zoom in here and let's see. The toolpath is calculated. I'll close this. And we're looking at it with the wireframe view. The tool is going to cut out here. Because it was a positive number, it's an undercut, meaning it's not cutting to the size. It's undercutting it. Another way we can check on this and see exactly what's going to be cut is if we toggle the viewing style from wireframe to solid. This is where the bit is actually going to cut. The wireframe view is showing you where the center of that bit's going to cut. The solid view is showing you the cutting diameter of the tool. And we see it's undercut. It's not cut to that size. This is where semantics or a lot of confusion comes in. Dave Braden, Sam Spade, you got it. Cutting less than the vector is an undercut, making your square bigger. 100% correct. Now, if I go back in here and I change that to a negative number, that's going to set up an overcut, meaning it's going to cut more than the vector, making this area smaller. And that's where a lot of the confusion comes in. Calculate, we'll close that, and now we see that bit cut way in here. Okay? So, the allowance offset, Ron Brockman says you can hold down the control key and then click on the calculate button in the 2D view to stay in the 2D view. Yes, you can. That's if you want it for this particular instance. And what Ron Brockman is saying, come in here. Oops. Come on. Come in here and wait, before you hit calculate, hold down the control key. Then click the calculate button and it'll stay in the 2D view like I have here. Now, I have in the options, up here, edit, options. I've set in the options not to automatically jump into the 2D view. Okay. 8 Center has an excellent question. Why would you choose to add allowances instead of just changing the size of the vector you're cutting? I'm with you. I'm with you 100% because that's what I do. I don't use allowance offsets. If I'm cutting, if I want to do a profile cut, I'm going to make the size of the vector the size I want the profile to be. I'm not going to, whoops, wrong. Yes, it is. Show advanced. I clicked that thing off. I'm not going to mess with the allowance offset. If I need this to be 10 thousandths smaller, I'm going to make the vector 10 thousandths smaller. However, there are instances where you might want to cut slightly smaller or slightly larger to be able to sand down to the proper dimension. Okay? I'm trying to think of an example off the top of my head, and I really can't. Okay, here we go. If you are cutting a profile of a part that needs to slot into another part, you might have to do a little bit of sanding to get that fit for an invisible seam, or as tight of a seam, as invisible as it can get. Yeah, kind of sort of like an inlay, but not exactly an inlay. If, you know, then you can cut it slightly oversized and then sand down to the dimension to get exactly what you need. And Michael Mazalik has an excellent example. If you have 1,000 vectors that need to be cut 1/100th smaller, the offset works better than drawing new vectors. Yeah, absolutely. I can see that. You were having an issue yourself, 8th Center, with needing to do a modification to a whole bunch of vectors. Well, this allows you to do that, and that's an excellent example, Michael. Thank you for that. So if you discover you've got to, oh my gosh, I got to make this, 10 thou smaller, you can come in here and add a 10 thou allowance offset. But let's see how that works. So that's with a closed vector. How does it work with an open vector? So I've selected this vector now, and this is something new to version 12 of the software. We've got this black square down here. That's telling you the start point of an open vector. So you can easily see without going into node edit mode. I'll go into node edit mode here. Just tap the letter N on my keyboard. Boom. We can see that green start point. Well, they have incorporated into version 12 and higher. There's your start point. You don't have to go into node editing. So that's important for us to keep in mind. All right. Let's see here. Brooks Martin has said, I had to have a tight fit for a coaster in the jig and creep up on the pocket size. Yeah, there you go. That gets into pocket allowance, and we'll get that in just a minute. Wendell is also adding, or to adjust for tool diameter difference than the actual bit size. Excellent point. If your 1/4 inch end mill in this case isn't exactly 0.25, let's say it's 0.248, you can get in there and you can adjust that so that it's represented out here. So you're making up for the actual tool diameter versus what the software says. So another excellent point. But anyway, let's get into what happens with an open vector. We're machining to the outside right. Remember, and this is hard for some people to wrap their head around, on a closed vector, we're cutting to the outside. On an open vector, we're cutting to the right side of that vector in relation to the start point. Again, imagine that you're standing on that start point and you're looking in the direction of the travel of that vector. So you're standing here looking this way, you're telling it to cut to the right of that vector when you're cutting to the outside. Let's see what that looks like with an allowance offset of 0. And we'll calculate that. And we'll see that that bit is cutting to the right of that vector. Okay? Well, now let's go back in and let's add an allowance offset. If we go with a positive number, the positive number is going to undercut that vector. So let's go with a positive of 0.25. Again, a completely outlandish number just to demonstrate the point. We're going to calculate it, and it's undercut that vector, letting you sneak up on what it's actually supposed to be. Both either in the finished part outside on the machine, or here sneaking up on what tab A is supposed to go into slot B. Now, Pete says it might be better to adjust the tool diameter in the tool database. That is true. However, I probably have a dozen 1/4-inch end mills. Do I want to put a dozen 1/4-inch end mills in my tool database? And how do I identify which one is which? So if I just have one 1/4-inch end mill in my tool database, and I have marked the case of one of those 1/4-inch end mills that say, no, this is actually 0.248, I know if I'm going to use that bit, I can adjust using the edit right here. I can adjust that. Or I can adjust it with a allowance offset. So again, as Michael Mazalik likes to say, nice segue, huh, Michael? There are 3 answers to every question. There are 3 answers to every question. And everything you said is 100% correct, Pete, if that works for you. So, 8 Centers says, if you have a dozen 1/4 inches and all of them are a different size, it's probably better to replace them. That may be. However, if you check the actual cutting diameter, you can go through a lot of perfectly good bits that way. You know? So, I mean, yeah, you could go through and replace them, and you can check bits till the cows come home until you have a good selection of bits that are all cutting the exact same diameter. I mean, that's up to you. But I'm too Scottish to throw away a perfectly good bit. So, that's just me. I mean, you know, what works for you, works for you. All right. But let's change to a negative allowance offset. And let's go ahead and calculate that. And we see now it cuts to the other side. It overcuts the vector. Here's the vector we want to cut. This is overcutting it. This is undercutting it. Only because that's what we have this set for. Okay. Now, let's try it inside the vector. We know on a closed vector, that's going to cut inside, like this has. But let's recalculate here with an allowance offset of negative 0.25. Boom, it goes back over here because we have told it we're going to cut to the inside of a closed vector or the outside, or excuse me, to the left of an open vector. But then we put in a negative number. So it shifted over here because we've told it to overcut. Michael is asking, shouldn't the offset on an open vector also include the y direction? I'm going to take these descriptions as literal in that on an open vector, looking at it, Michael, it did. There's my vector. There's my overcut. Let's take that away and make it 0. It's an excellent point. No, it didn't. It didn't change it at all. It put the center of the bit right where that start point is. And it cut right to the end. The center of that bit went to the start point. That's an excellent point, Michael. It should cut your allowance offset. It should overcut this direction as well, or undercut it, depending upon what you want. Dang. We might want to ask Vectric about that. We might want to ask Vectric about that. Because that's an excellent point. Let's get goofy here. Let's set this allowance offset, because I've got the allowance offset that I'm checking with the same size. I'm using the same allowance offset as the diameter of the bit. Let's go for 1 inch, just to be stupid. Okay, it did not cut an inch longer. It only cut, in this case, to the left by that allowance offset. But using your logic, Michael, and you're 100% correct, wouldn't that also include overcutting it or undercutting it in this direction? Dang. Excellent point. Eight Center says, I don't think so because it's based on the position and direction of the start point. True. And it's only cutting parallel to it. It shouldn't cut past the length. I see where you're going, and I agree with you. That would be a different feature, like an outlead. Yeah, like a lead in or lead out. Yeah, I can see that. And when you think about it, 8th Center, that would also negate the need for a lead. Maybe you want another lead other than whatever the allowance offset is. Okay. Well, let's try 1 inch on the vector. Let's see what happens. Okay, so we've clicked on the vector, and we got an allowance offset of 1.0 here, but it's grayed out. It won't let me put an allowance offset when I'm machining on the vector. I have to be either cutting to the inside left or the outside right of that vector. Why would you want to overcut on an open vector by the allowance? Again, if you have 1,000 open vectors, do you want to go back and change all of those vectors to the correct size, or just put in an allowance that would compensate for all of those vectors, that would compensate for what you need on all of those vectors at once? There's a lot of cases where you would want to do that. Wendell says to adjust for Y, you would have to have a second vector to calculate the adjustment. You would probably want to replace that vector, yes. Yes. Because right here we're telling it to cut to the outside or right of the vector. That's a good point. I will bring that. I will bring that up. I'll talk to somebody at Vectric about that, and I hope Michael will too, because the squeaky wheel gets the grease, and if we can get an answer, um, I'll sure do it. Used to do this all the time in manual code writing. You people that do manual code writing, to me, are absolute flippin' wizards. I don't know how you sat down and wrote out G code manually. I mean, I think y'all are from another planet or something. Let's reset the preview so we don't have any of those, and let's undraw. Well, that may be the case there, Wendell, but you have my respect, because I don't know how the heck you did it. I really don't. So, but another thing to understand about these allowances, all right? Oh, I don't know why that happened. I know why, because I double-clicked it, and it just happened to uncheck the Advanced Toolpaths option. One thing to understand about all of these allowances, and this might be the answer to our question, Michael, when we're talking about these allowance offsets, we know that it's based off of the start point and which direction that vector was drawn in, but the allowance offset will not change the cut depth. If you have a cut depth of 0.25 and then you put in an allowance offset, let's get stupid again and say 1.0. We'll select that vector for example, and we'll calculate that toolpath. And let's go ahead, close this, and jump into the 3D view and watch this preview. It did not cut that 1.25 inches. Okay, if we slip in here and we watch my readouts down here, look for the Z readout, which is all the way to the far right there on the bottom. I'm at 0 right here, and I come down here, I'm at negative 0.25. So the allowance offset, let's go back into it. The allowance offset down here does not affect the Z-axis. It does not affect the cut depth. Okay, let's go back into the 2D view here. I'm going to close this up because Dale B is asking what happens on a horizontal line. Well, let's look at it. Let me jump over here real quick into my design tab, and I'll draw a horizontal line, say right there. Boom. And we'll close. There's my start point, and that's the direction I drew the line in. So let's go, I'll just do a new profile toolpath. Same cutting depth, and we're going to go to the inside or left. Now, we got to remember, we're standing on this, facing this direction. To the left is going to cut out here. Well, I don't want to cut off of the material, so let's go to the outside or right. That means it's going to cut down here. Without an allowance offset, the edge of that bit would be right here. If we go with a, what are we doing? We're undercutting, so I'm going to use a negative 0.5 just as an illustration. I wouldn't use that. I would change the location of this. And we will calculate, and now we see it's cut up here by a 1/2 inch. Okay, that doesn't mean the center of this bit is, or it doesn't mean this edge of the bit is a 1/2 inch away from the vector. It means the center of the bit cut a 1/2 inch away from this vector. Okay? It's an overcut based on the negative or positive, whichever you entered here, based on the center of the bit. Okay? If we go with, again, with 0, calculate, this edge is going to run right on the vector. Okay. Now we'll go with a positive number, 0.5, calculate it, and it moved it down this way. We're undercutting the vector because we're not cutting up to it. So a negative allowance offset will cross the vector. Yes, it will overcut. You'll cut beyond the vector. A positive number will undercut. You're not cutting up to the vector. Wendell says, if the second vector is 90 degrees to the first, then the radius of the cutter is added to the Y move to place the cutter to cut the second vector. Let's try that. So a negative allowance will cross the vector. Yes. Yes. Let's get into that here. Close that, and we'll undraw that. I'm going to take these two right here, and I'm going to join them. Let's use a straight line. Shaboom. Okay, we have this corner. Okay? But it's one vector. Start point's here, and it's being drawn in this direction. So we'll go back into profile. Come on. Open this up. Because we've changed the vector, it's no longer selected. We'll have to reselect it. Let's go an allowance offset of 0. Come down and calculate. And we see, because we're cutting to the outside or right of the vector, remember, standing on the start point, looking in the direction, we're cutting to the right of the vector. If we want to undercut it, we'll add a positive allowance. We'll go with 0.5 just because it's huge and you'll see what I'm talking about. And we'll calculate it. Now the center of the bit has cut a ½ inch. Again, to the right, it's undercut. We haven't cut up to the vector. We make that a negative number. Calculate. Now it's overcut that vector, making it small. It makes sense that you would not want the allowance offset to change the dimensions of the resulting cut. Yes. To a point. For instance, if we draw a center line here, an imaginary center line here, and we get to this corner specifically, we have a 45-degree angle here, or roughly a 45-degree angle here. If we measure from this point here to this point here, it is going to be dimensionally smaller than the measurement from this point here to this point here, but only because it had to make it smaller to compensate for the diameter of the bit and to compensate for the distance it overcut in this time. As a Marine, I have trouble spelling G-code, let alone try to write a full program. I was never a Marine, Butch, but I'm with you. I was an Army puke. I'm with you. So that is what the allowance offset is, and that's what it does. How you choose to use it, whether you use it or not, is 100% up to you. I'm kind of in the same camp with 8 center in that if I need it to cut smaller, I'll adjust the vector. But then again, if I've got 150 vectors, it's easier just to add an allowance offset to the entire toolpath rather than go back and change 150 vectors. So that's what the allowance offset does for on a profile toolpath. Now let me go ahead and we're going to delete this, all of it. Delete all, shaboom. No more toolpaths, because what I'm going to do, and I'm going to delete this because I don't need it. No, I will keep it open just for one demonstration. Now we're going to talk about a pocket allowance, and that's in the Pocket toolpath. So we'll go into the Pocket toolpath, and we're talking about way down here, a pocket allowance. All right? A pocket allowance is used basically, let me zoom in here a little bit better, to leave a thin wall of material around the edges of the pocket. So unlike in the profile toolpath where we're cutting tab A to fit into slot B, now we're cutting slot B to fit around tab A. So a positive value, and this is where a lot of people get confused on the pocket allowance, a positive value will leave that thin wall. So it will cut to the inside of the vector. Remember, the purpose of a pocket toolpath is to machine all of this material away, either up to the vector or using the pocket allowance a little bit inside that vector to give you an area to sand to fit whatever is supposed to go in here. Well, why wouldn't you just cut it? To fit? Cut the other one to fit. Well, what if the other one is a piece of material that you can't cut? Maybe you're machining something that's supposed to go around the edge of a marble countertop, or maybe it's supposed to fit a brass rod. There's a little bit of give in there, say for instance marble, that is not perfectly flat. Maybe the surface has a few little waves in it. But you have to be able to, you can't sand that marble perfectly flat, but you can cut a pocket to go around that piece of marble that you can scribe to fit perfectly. But this is removing the bulk of the material. There are several situations where you'd want to leave a little bit of material so that you could scribe a line to get it to fit as perfectly as possible. Now, if you should discover that maybe it's in the opposite direction, you need to cut a little bit outside, make the pocket a little bit bigger, that's when you would go with a negative number. And this is the one that trips people up. Using a negative number, you are, again, undercutting. Now I've got that backwards. See, I went and did it. You want an overcut, you're going to cut right here to the inside, a negative number. If you want an undercut, positive number out here. It makes a little bit of sense if you think about it. Let's do where are you? There you are, pocket allowance. Let's go with a stupid pocket allowance of 0.5. And we'll calculate it. Now that's a positive number. meaning it undercut the pocket. It didn't cut out to here. It's an undercut. Let's change that to a negative number. Zip. Calculate. And it overcut. Or excuse me, it undercut. Meaning it cut larger. This gets confusing for a lot of folks. Again, you have instances where you want to leave a little bit of material here, and so you'll use a negative number to overcut to allow you to scribe to a smaller size. This, on the other hand, for instance, you've got 22 pockets that you need to cut, all on the same toolpath. You can just put that allowance in there, and it'll affect all 22. You don't have to redraw 22 vectors. There are instances where you will need either or. But then again, I'm kind of along the same lines. I, generally speaking, don't have 35 different pockets I got to cut on the same toolpath. Generally speaking, if I need one cut to be a certain size, I can make it that certain size. If I'll just make the vector that size. But I can see where there would be a need to make that pocket either a little bit wider than the vector or a little bit smaller than the vector. I didn't mean to say wider. I meant larger than the vector or smaller than the vector. When it comes to memory, mine is kind of sort of like a sieve on some of this stuff. I tease and joke about it in that I can't remember what I had for dinner last night, let alone whether a positive pocket allowance will cut out here or a negative pocket allowance will cut out here. So my cheat, my go-to, calculate both. Calculate both until you get what you need. Again, 3 answers to every question. If you know it by rote, my hat's off to you. I don't. So I'll try it with a positive pocket allowance, and if that don't get me what I want, I'll switch over to a negative pocket allowance and go from there. So, again, 0 pocket allowance. It cuts, oops, I'm trying to spin it around like it's a 3D view. It'll cut the vector up to the vector. So, thank you for the assist, 8th Center. You're absolutely right. You had what Linda put on your plate. You're absolutely right. And I do remember it was KFC. I remember because I drove. Anyhow, that's more than you wanted to know. All right. So the other thing to remember about the pocket allowance is, much like the allowance offset in the profile toolpath, it does not affect the cut depth. If you have a cut depth, in this case of 1/4 of an inch, it's going to cut 1/4 of an inch deep regardless of what your pocket allowance is. This does not affect the cut depth. If you need a deeper cut depth, you can either adjust your start depth or you can adjust the cut depth. Generally speaking, I would adjust the cut depth. About the only time you want to mess with the start depth is, let's say you've already machined away a pocket out here, and now you've got to machine this a little bit deeper. You don't want it to cut air. You can start at the surface level of the other pocket. So, Eighth Center says, it makes sense in prototyping to use pocket allowances to dial things in. But after that, it's definitely better to adjust the raw file sizes once you know the offsets that fit. True. And I get where you're going, especially if you're in a production environment. But if you're like me, where basically, to be honest, we have a house full of prototypes because once I make something and it works, I very rarely go back and make it again. So I get what you're saying. I get exactly what you're saying. If you're prototyping something to keep doing it over and over, using allowances to dial things in, and then eventually getting everything dialed in and set and ready and adjust the raw file sizes. That's a good point. That's an excellent point. So that is the difference between a pocket allowance in the pocketing toolpath and the allowance offset in the profile toolpath. You folks have had some great questions, and I do appreciate it. Let's see. Indeed, I'm trying to get to production levels, so it's a part of my thinking. And you have to think that way if you're going to get into production. You have to think that way. So your concerns are 100% legit. So, let's see. We were also, time permitting, going to talk about a separate last pass. Let's get rid of this. Bonk. And we'll delete that pocket toolpath. Let's go back into the profile toolpath here. And Mark, you got to quit double clicking. We're talking about a separate last pass, and that's right here in your advanced options, okay? This does not change any dimensions, okay? Let's say we're going to cut, machine this, and we're going to machine to the outside. We want to cut this out. We want this to drop away and leave a hole, okay? We can look here. We're going to cut the thickness of the material because we're going to cut it out. So Z equals. I've got my material thickness. We're going to cut all the way through the material. And it's going to do it in 3 passes. Okay? If you have ever had dwell marks or witness marks when the bit cuts level by level in 3 passes, for instance, or if you look at where the start point was, let's go ahead and let's calculate this and take a look at it. All right, jump into the 3D view and we'll take a look at it. My XY datum position is in the center. That means if you look at this red line, that is a rapid move. This gets into reading these toolpaths. A red line is a rapid move. Then we got over here, we have a light blue line. The light blue line is a plunge move. Okay? It's going to plunge down to this first level. These dark blue lines are the actual cutting paths of the bit. It's going to move over here, a rapid move with the bit not in the material. Then it's going to plunge down to this first level, and it's going to go along its merry way, cutting. Then when it gets all the way around, it's going to drop down to this level and move along and cut. Get all the way around, come down here, and so on, and finally finish the cut and cut all the way through the material. If you have ever noticed little dimples along this area here, those are dwell marks. Where the bit is plunging into the material, it's actually making a slight little cut right there. And you can see it when you look at the edge of the material. Well, one way to help get rid of those is to use a ramp. You ramp in. I tend to use a smooth ramp. that's equal to at least double the bit's cutting diameter. So in this case, it's a 1/4 inch end mill. The minimum distance I would use would be 0.5. If I want to make that slightly bigger, slightly longer, I can change whatever distance. Now, that will help in that, I'll go ahead and calculate it and you'll see. Boom. Instead of plunging in straight down, it's going to take a 1/2 inch to plunge to that next level right here. Then it's going to come around to this point and it's going to start ramping into the next level. You get my point. It's going to keep doing that. Then it introduces this green line here. A light blue line is a plunge move. A green line is a retract move. So that bit is going to come out of here. It's going to retract right here. Then move back over to your XY datum position, the home position. 8 Center is asking, which comes first, the last pass or the allowance offset? I'm guessing last takes priority and is always cut last. Last doesn't necessarily take priority. It will cut, but it does cut last. And that's what I'm getting ready to show, because remember, all of this is without a separate last pass. We calculated that. Now, I'm going to introduce a separate last pass. A separate last pass does not work in conjunction with an allowance offset, and it doesn't take precedence over allowance offset. It's a different process. We're going to do a last pass, and we're just going to be stupid with this so you can really see what it's doing. We're going to go with a 0.5 just so you can see it demonstrated out here. Do a separate last pass with an allowance of 0.5. And we're going to come down here and we're going to calculate it. Warning, large last pass allowance. And this is a warning to let you know you may be in trouble. The last pass allowance is large in relation to the tool diameter. I hadn't thought of that. I'm using a 1/4 inch bit. Now I'm asking it to do a separate last pass that's bigger than the cutting diameter of the bit. This means the tool will be cutting a significant amount of the tool diameter for the full depth of the material. I didn't think about this warning, so let's do this. Let's go with a 0.25. It's equal to the diameter. Calculate. I still got that. Cancel. I didn't think this through. I thought it would let me do it. Let's go with 0.24. Still got. All right, I'm just going to say okay, to show you what the last pass is going to do. When I do a separate last pass, look at where these vectors are. Where these, rather, they're not vectors, they're lines, the blue lines. The dark blue lines are the actual cut. Remember, we're reading a toolpath rendering here. Red is the XY datum position. Rapid moving over to the first plunge. Okay? That first plunge is going to ramp in and start cutting. Here. It's going to move all the way around. Then it's going to ramp down to here. The second cut. Okay? Trying to get over here so that it's... There we are. It's going to ramp down and it's going to cut here on the first pass. Then it's going to ramp in, go all the way around to here. Then it's going to ramp down for the second pass. And that's going to come all the way around and cut to here. Then for the last pass, because there's only 3 passes, it's going to retract and move in, rapid in, to cut to the size, the actual size of the vector. So you see, if I'm looking straight down, these are the first 2 cuts. This is the last pass. Okay? That last pass is going to cut the entire thickness of the material all the way around the vector to get it to the proper size. I never use a separate last pass with this much of an allowance. My go-to, my default, and I do this on almost every profile, outside profile especially, that I cut. But I do inside profiles as well. My default, my go-to is always 0.01. Now if we calculate and look at that, you see how tight that is. That it doesn't really, you can't really see that these 2 are going to cut oversize and this is going to cut to the final dimension. The reason for doing a separate last pass, and again, all my plunge moves are exactly the same. The reason for doing a separate last pass is to remove those dwell marks of where the plunge and the retract took place. It's to, and also remove the marks, the witness marks made by machining all 3 passes. The last pass is going to ramp, it's going to, you can see here if you look real close, after this, in this case, second pass is finished, it's going to retract, move in that 10 thousandths, then ramp down and cut the full thickness of the material at once. It's going to remove the dwell marks made when the bit plunges in, and it's going to remove those witness marks made by each pass as it cuts to the next depth. Separate last pass I do on almost every profile. It adds maybe 1/10 of a second to the machine time, because the only thing it's doing is lifting out of the material, rapiding over the allowance amount, in this case 10 thousandths of an inch, then ramping down and cutting the full thickness. Now, if you're concerned about your CNC router being able to cut, in this case, 3/4 inch thick material all in one pass, all in one go, remember, it's way out here in what's already been cut. The only thing it's cutting is 10 thousandths of an inch. It's trimming 10 thousandths of an inch off of your material all the way around. And it's going to remove all of those witness marks and leave you probably the best finish you're ever going to get on a profile, whether you're cutting to the inside or the outside of the vector. So a separate last pass has nothing to do with an allowance offset. If you have an allowance offset here of 0.5, let's go stupid again, and you do a separate last pass of 0.01, and you're ramping, 1/2 inch ramp, we calculate, you can see that all of those passes are going to be cut to that size of the allowance offset. All the separate last pass does is adjust where that last pass is going to be cut. It makes the previous passes cut oversize by the allowance. Then the last pass will cut to the vector size or to the allowance offset size. That's all it does. So you do have, now here we go. Ken Armstrong is asking, is it better to do the last pass in the opposite direction, or does it even matter? I can only speak anecdotally. Other people may have other experiences with this, but I have never found a reason to reverse the direction. I would say close to 100% of my cuts I cut conventional, and I don't reverse directions. I have yet to find a case where I needed to do that. Now, your mileage may vary. You may be, now even that wouldn't work. So use your discretion. And this is another, okay, Wendell is saying depends on the material, trial and error. And that's what I was going to say. This is another case where you practice and scrap. If you're working with a new material or a new species of wood that you've never used before, what I tend to do when I buy my material, I buy more than I need, knowing that I'm going to have mistakes and knowing that I'm going to need to practice to try things out and see what this material's like. So if it turns out that your material needs you to cut in the opposite direction, okay, Michael Mazalik is saying here, you reverse direction for cutting acrylic. I had no idea that you did that. I really had no idea that you would reverse the direction when you're cutting acrylic. So, okay. And that's what I mean. You folks have done a lot more in other materials than I have. Well, some of you. Some of you are beginners. Some of you are intermediate like myself. I've not had a lot of experience cutting acrylic. And my experience with cutting acrylic is get that sucker cut as quickly as you can so it don't melt to the bit. So it's generally speaking been 1/8 inch to 1/4 inch material, 1 to 2 passes. So I've never machined in thicker material, thicker acrylic. But the separate last pass is used to get rid of dwell marks in straight plunges. And you don't have to use ramps if you're doing a separate last pass. You can do a standard plunge. I prefer to use a ramp because a combination of adding a smooth ramp with over a distance of at least double the bit's cutting diameter has always worked for me. You can go bigger if you want. If you want to make that 3/4 inch, you're fine. But I tend to use double the end mill's cutting diameter. This is getting off topic, but this is crucial when you're talking about large bits like surfacing bits, where you have cutting edges on the outside edges of the surfacing bit, but it's not made to plunge straight down. You add a ramp, double the diameter of the cutter. For instance, my surfacing bit, when I surface my spoil board or surface any piece of material, I ramp that 2-inch diameter surfacing bit, I ramp it over a 4-inch distance. So it does work and it does help, but it's crucial on a bit or cutter that does not have a cutting edge all the way across the bottom, because you do not want the bottom of that bit to bottom out on the surface of your material, because things are going to get real exciting real fast and the outcome is not going to be good. So that's kind of off topic, but it's just fair warning. The allowance offset has to do with the dimension of the final part, or the final, in this case, hole inside the material. The separate last pass has to do only with where that last pass is going to be cut, either to your allowance offset if you have one, or not if you don't have one. So that's what the separate last pass does. It is very specific. Can I set the ramp length and depth? You can set the ramp length here. The ramp depth is going to be based on the number of passes. This is another subject, but since it was brought up, we'll go ahead and talk about it. You can edit the number of passes that you make, and you can edit how those passes are made. And it will work in conjunction with the allowance that you've set here on separate last pass, or not. Okay, Pete's asking, what do you mean that separate last pass and allowance offset won't work together, or did I misunderstand that? If I said that, Pete, I misspoke. They do work together, but they're separate operations is what I'm getting at. They do work together because either the part you're cutting out or the hole you're cutting out will be machined to the allowance offset. The separate last pass is just going to be, it's going to regulate where those previous passes were. So they take one another into account is what I'm getting at. So I will get to that in just a minute. I didn't mean to do that. I will show you that in just a minute. Let's see here. What was I doing? So they do all work with one another, Pete. Now, setting the ramp length is done here. The ramp depth is based on the number of passes you have. And again, you can edit the number of passes just by clicking Edit Passes. And there is a way to do all of this. This is worthy of another video itself. We can do this next week if you'd like. But the short answer to the long question is you control the number of passes down here. Okay? We're making 3 passes at 1/4 inch per pass. If you decide that's too much, you might want to go in and edit the pass depth of your bit in the tool database, but here you can change the number of passes. I've just changed from 3 to 6, and we now see where those passes are going to be in the thickness of the material. And we can see those depths right here. Now we've gone from 3 passes at 1/4 inch per pass, and now we've got 6 passes at 1/8 inch per pass. So we can adjust the number of passes here, then set those passes, then click OK, and now we've got 6 passes. What this does, after I recalculate, we're using our allowance offset and our separate last pass, are ramping in a distance of 1/2 inch. Let's calculate it. No vector selected. Well, Mark, select the vector. There we go. Calculate it. And now we see it has increased the number of passes. And that has changed the depth of each ramp. So that's how you change the depth of each ramp. The length of each ramp is changed right here. I think it's worthy of its own live stream, and I think we'll do this next week, is get into specifying the pass depths, editing the number of passes, because this is something that's worthwhile as well. So click cancel on this. So note to self, edit passes next week. All right. Okay, so there it is. Separate last pass is basically the whole reason for this is removing dwell marks where the bit plunges in and removing witness marks where the bit is cut each level. And I'm using my hands like you can see what I'm doing here. So it's to eliminate those witness marks as it plunges down into each level, giving you a nice clean edge where it looks like you cut the whole thing in one pass, because technically you have, but you're only removing, again, in this case, 10/1000ths of an inch. And I'm here to tell you, I came up with this number, that 10/1000ths of an inch, using a CNC router that was made out of plywood. And it was not the most rigid thing in the world. It was plenty rigid enough for what I do. But if it'll work on a plywood CNC router, it'll work on yours, okay? Because you're only removing, again, 10/1000ths of an inch, cutting on the side of the edge of that material. So, we've got some other questions out here that I am going to get to. I promised I would. If you have any question about either allowance offset or separate last pass or pocket allowances, by all means, feel free to put them here in the chat. Now, Pete over at Nature's Live Edge, who is an absolute artist, I'm here to tell you. The guy knows what he's doing. Let me just say that. Pete, you're a wizard, I'm telling you. Says, I'm going to be making some marble board games for Christmas. Any recommendation on bits, techniques, etc. for milling the marble locations? I had an email from someone asking me something similar to this. And that was he wanted to make dimpled pockets to hold golf balls for a display. And my answer remains the same. So it depends on how you're cutting the rest of the project. Do you want these marble locations? Do you want, are they part of a 3D model? Are they part of a 3D carve? If they are, you can use the clip art dome/dish and experiment a little. Play with a couple on a piece of scrap whatever. For instance, I've got some particle wood shelves here that somebody was throwing out. That's great for practicing this kind of thing. And size those little dishes and figure out which one works for you for the marble location. And that's if you're carving the whole surface and there's a 3D model in the middle or something of that nature. Another way to do it would be simply use a core box bit or a end mill. That is the appropriate diameter. If you have for instance, a 1/2 inch ball nose or a 1/2 inch diameter core box bit, you can plunge in, say, 1/8 of an inch and see if that's enough to hold a marble in that location that you need. In which case you just draw circles for each of your marble locations, put them all on one layer, and associate a toolpath. You would use, you could use a drilling toolpath for that and just drill, say, a 1/16 of an inch or 1/8 of an inch. And it will come along and it will boop, 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 do all of those. If you wanted to use a 1/4 inch, I wouldn't do that. I wouldn't do that. What I'm getting at is there are many, 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 many ways of doing the same thing. As Michael will tell you, 3 answers. 3 answers. Bits, techniques for milling the marble locations. again, that's such an open book. It really can go in so many different directions. Okay, Flaker's carving. I said we'd get back to that, and the time is now. When you want to pin the alignment, like I have down here, the align objects, what you're going to do is you're going to come up over here into, I'm sitting here, I was pointing at the wrong screen. We're talking about this down here, the align objects. You're going to go into the align objects menu, and you're going to come all the way down to the bottom, show common tools on the design tab. Okay, I've got a check mark there. If I uncheck it, close this, I don't have any alignment tools. But if I check it, then click close, there are my align objects on my design tab. So I hope that helps you out. Oh, itching. Okay. 8 Center says, if anyone knows it, I got the new update this week. I'm assuming you meaning to 12.5. But I don't like these patches all the time. Are the raw full versions with the updates already stored somewhere on Vectric website? Yes. If you go over to the Vectric website now and you download your software, what you'll have to do is you'll have to go into your V&Co account. Let me go into my V&Co account here. And I will show you. I'm going to log in. Then I'm going to open up a window because you don't need to know my login. There we go. All right. So I've logged in. Your software. So I click on my software. If you download this, VCard Pro, let's say, up to date. If you download this now, you don't need to see that either. Yeah, if you download this now, you will be downloading the most recent edition. Let's go with the Spire 12.5 because I have a Spire now. If I download this, I will be getting version 12.506. Now, as far as those patches are concerned, those patches are important, and they come out as needed when people discover problems, when they discover bugs, or a crash happens. When you download a new version of the software, or when you patch it, it's going to have release notes attached to it. So if I go to click on, okay, what I did was I went to Help and clicked on Release Notes. What it's going to give me is this. Bring it up. Come on. And these are the release notes for version 12.506. This is what the reason for the patch. You can see right here, there are 2 crashes that it fixed. Fixed an undo redo issues with markers. Fixed an issue where form values could be incorrect. I mean, there are a lot of issues, a lot of crashes that they can only beta test so much. There are so many things that are variables. They don't know your computer. They don't know what you have running in the background. They don't know what your ISP, or your, not ISP, what your antivirus software is doing. So with a bunch of things going on out there, They're going to fix stuff. Let's see here. I get the patch reasons. Okay. It's just some of them seem to slow things down more than not. Like 12.504 seemed very buggy. I would rather install it as separate software if I need to go back for smoothness. I get it. I don't think there's a way to go back. Michael maybe knows if I'm wrong. I don't know if there's a way to go back. Like you were talking about version 12.504, you preferred 503. I don't think that I don't think there's a way you can go back. Um, yes, you can go to the read and code account. And you can go to your software. Having said that, I don't know if that's going to be counted as self-install or if that is going to be what you've already got. If that makes any sense. Butch Miller has been he's been here for me. I love aggregation games, and okay. Um, unless that 3-year-old happens to be wearing a dilly bar, then all bets are off, right, Bush? What can I say? Mark, your voice is digital artifacting, and Jam. Kurt says Mark's screen went black. Am I having issues here? Am I having audio or visual? Mark, you are garbled and losing connection. Well, and here I just went all lost everything. Back now, better now. Oh, that's better. I don't know what that was. I don't know what that was. Kurt said my screen went black, and everybody said my audio got. Must be a YouTube thing. I was just bragging about being hardwired into my router. And I'm not getting any warnings about being offline. So I'm back now? Okay. Lost since about you can't really go back. Michael Mazalik might know. Okay. Well, all I was pointing out was that Butch Miller had mentioned something here. There we go. Butch Miller said, I make a lot of aggravation games. I use a 5/8 inch core box bit, holds marbles well so you can pick them up, yet won't dislodge easily when a 3-year-old bumps the board. My comment to that was, unless said 3-year-old is wearing a dilly bar, in which case all bets are off. What can I say? It's an inside joke. The only thing I'd ask Butch would be, how deep are you cutting with that core box bit? 5/8 core box. You know what? I have a 5/8 core box bit. Oh, okay. There you go. You just mentioned it. I use a drilling toolpath and 0.15 depth. Perfect. There you go. Anybody looking for the little marble dimples? 5/8 inch core box bit, drilling toolpath, 0.15 depth. I like it. Thank you, Butch. Appreciate it. See, you guys are some of the best people out there, man. Lots of neat little tips and tricks like that. All right. Let's see. There was one final question that I'm going to get to today. And that was, again, from 8th Center. What I haven't been able to figure out, though, is how you would insert math like x minus 54 millimeters when the material is set in inches, or vice versa, taking off a ½ inch when set to millimeters. The calculators built into the software are pretty sophisticated. So if you get in, let's bring this back here. We'll spotlight it. The calculators are pretty sophisticated. So let's close this, and I'm going to undraw it. In fact, I'll reset the preview just so I don't get distracted. I'm going to go back over here to the Design tab. And we'll jump into the 2D view. See, what am I going to use to demonstrate this? I'll delete these vectors here just to get rid of them. Shaboom. And we're going to draw a rectangle. And we're going to put that rectangle, the center of that rectangle, is going to be at the X0, Y0. Square corners. The width is going to be, let's use your example. We're going to go, our width is going to be X minus 54. Now, here is the answer to this. We're going to convert millimeters to inches because I'm working with imperial. So what I want to do is hit asterisk I. What that is telling it to do is convert that 54 millimeters to imperial dimensions. Then I'll tap equals, and there it is entered, the equivalent. It has done the math for me. Okay? We come down here, and we're going to go y minus 54 asterisk I equals, and now I've created a rectangle that is 54 millimeters smaller than my material. The opposite, if you're converting from imperial to metric, is asterisk M. That saves you from typing out the 25.4 divided by 2 and all that other good stuff. Asterisk M to convert to metric. Asterisk I to convert to imperial. These calculators are pretty sophisticated. They will do the math for you. Let's get stupid. We're going to go X minus 54 asterisk I plus 0.25 equals, and there's my measurement. I've just subtracted 54 millimeters from my width in X and then added a 1/4 inch. I thought maybe you had to use brackets or something. I mean, you know what? Between you and me, man, they said there'd be no math. If it needs brackets, it's above my head. I'll take it in 2 or 3 steps. Exactly. I know, right? I know. Yeah, they said there'd be no math. Well, they lied, and it's just plain and simple. Wugzug, I love that name. That's crazy simple math I didn't know. Yeah. Yeah. Because I got an error with one saying too many decimals or something. Yeah, you just got to remember that asterisk, and then I to convert to imperial, or M to convert to metric. And Sam says, I just took my shoes off to do it. Yeah, but I'm screwed when I get over 20, you know. So I never should have written Math Sucks on the cover of that book. Anyway, we went through a lot of topics, and I hope I answered everybody's questions. I kind of alluded to something a little bit earlier about 4 different times. And he has no idea that I was even going to mention this. If you look down in the description of all of these live streams, you will find permanently linked there a link to Michael Mazalik's YouTube channel. I sincerely hope you go over there and click on that link and go over to Michael's channel and not only binge watch everything he's put out, because the guy is just a wizard, I'm telling you. You will learn more about 2D and 3D than you'll realize. He is starting a new venture that I have absolutely no idea what he's doing. I'm going to talk to him about it a little bit later on this afternoon, hopefully. But it's called 3 Answers. Michael has a penchant for showing folks, and that's part of the reason I say binge watch his channel, that no matter what question you have, there is almost always 3 answers to that question. And he will demonstrate those 3 ways of doing something in his videos. The man is excellent. Yeah, boom. There we go. You've got the asterisk on the wrong place. It should be asterisk I. Asterisk I. There we go. Steve is right on it, but I mean, Michael's channel, there's a link to it. Get over there and, as I say, binge watch. He's got a new, I'm just going to say, a new adventure coming. And if I know Michael, it's going to be well worth it. And it's called 3 Answers. Keep an eye open, keep an ear open, because you're going to be hearing about it. And I'll have more about it later on once I find out what it's all about. But Michael is a stand-up guy. He knows his stuff. He's been using the Vectric software for many, many moons. And he's just a good guy. He's just a good guy, a good man. So show him some love, show him some respect. Head over to his channel, subscribe, binge watch, and, enjoy. Channel members, tomorrow we're going to have a little bit more fun with 3D and AI because some new software has finally been released. An update to VistaSculpt. Michael Bernasconi is going to help me dive into it. It's going to be fun. Promises to be fun. And these guys have been just absolutely going crazy with the projects, and you're going to see it. Let's see. Next week, as I say, we're going to get into setting pass depths, and we're going to edit passes and what have you. I forgot to say, channel members, remember we're on the new time schedule. That's going to be the default from now on. We'll be starting at 5 p.m. Pacific, 8 p.m. Eastern for all of our members-only live streams. Don't forget to check the membership/posts tab on my YouTube channel, and you will find the link there to the members-only live streams. If you don't know what I'm talking about, or if you'd like some information on becoming a channel member, down below this video panel somewhere, you'll see the word join. Click on that button. Relax, you're not joining anything. You're under no obligation. It's just going to pop up a video that's going to tell you all about channel membership. We've got an excellent group of people that really like that. I don't know that they like to, but they ding dong sure go above and beyond to help one another out. And they're doing some absolute, they're doing some museum quality work. So we'd love to have you join this fantastic group of people. And then we can move on to next week. Again, we're going to get into setting passes and adjusting the passes. There's a lot you can do with that. Some of it I bet you'd never realized you could do. And other than that, I think that's about it. So thank you for spending, holy cow, an hour and, close to 2 hours of your Sunday with me. I truly appreciate it. Getting close to the end of the year, and we start getting into thinking about things that happened in 25 and as we look forward to 26. And I just can't reiterate enough how grateful I am to all of you. Thank you for spending part of your Sunday with me. Thank you for the comments, the suggestions, the thumbs up, the shares, all of it. Thank you to my channel members for creating the absolute best group of people I have ever been blessed to meet. And I will see you next week. Y'all take care. Have a great rest of your Sunday. Thank you.